Okay, here we go. Question 7. This is about linear projection. So it's very subtle. Like most of the algebra is pretty common. Like no different from like OLS or your linear regression knowledge. But it's about the mathematical argument, how you proceed your mathematical argument, the difference between assumption and definition and result, right? So in econometrics, linear regression is a model like that is we are making assumptions, and based on the assumptions we derive like estimators. But on the other hand, you may understand that as a linear projection, right? For example, you don't know what is going on, just you make a scatter plot and draw a slope, a line. Then what is the slope of the line, right? That is linear projection. It is about just drawing a line, right? So let's think about it. Suppose that you have a random variable y and a random vector x, and assume that the mean y is 0, mean of y is 0, mean of x is 0, and that full rank assumption. So these are the main assumptions. Actually, the mean variable assumption is not an assumption. It is normalization, so that's not a problem. So the only assumption I'm assuming here is invertibility, the full rank assumption. And then under this assumption, you can calculate this covariance and this variance, right? And then that is b. So this is the slope of the the line going through x and y, right? And then I will define v. By the way, this equality sign is definition, right? Equivalence. B is the capital B is always equal to this guy. It is not. It cannot be false. Then vi is defined as the residual. Okay, and then I'm going to show that the residual is orthogonal to the regressor x. Okay, so let me try this. It's pretty simple. I need to show that xi vi is 0, and vi is defined as yi minus xi transpose b. And then if you expand, it's xy minus expectation x xi transpose b. And using the definition of b, expectation xy minus expectation xi transpose xi transpose inverse expectation, I'm sorry, xiy. So then as you see, it cancels out, and then this cancels out. So it's obviously 0. I only use the definitions, right? So then the difference here is, like, it is very important to understand the difference. It is linear projection, right? So it is like calculating mean or calculating covariance, right? I don't need any assumptions. I don't need any model to calculate covariance. It is, so whenever you have like scatter plot x, y, and if you have observations like this, and then you are just drawing a line that go through those dots. So like it doesn't imply it is about covariance, or we usually say statistical association. Statistical association. It does not imply causation, right? So in econometrics, we usually want to say x causes y, but linear projection is just covariance. It doesn't imply which causes what.